Currently, I teach Algebra 2 Accelerated, Algebra 2, and Calculus BC. Los Gatos High School serves the town of Los Gatos. We have a student population of about 1,700, a very community-centered high school. The geometry students that I've typically taught for umpteen years are those kids for whom geometry is not or math in general is not their strong suit. So I was looking for something that would engage those kids who would benefit from something different than the traditional geometry curriculum. My fellowship experience at Lockheed Martin was in the solar array manufacturing division, and in that capacity I would tour the floor of the manufacturing facility, seeing all these different solar arrays hanging from the gantry, and I noticed they were different. There was one array had one shape of cell on it and another array had a different shape of cell on it, and I'm sitting there thinking, a solar cell is a solar cell, right? And so that question was something that I found myself wondering about, and that was kind of the seed of this project.
I teach with Kevin Jordan at Los Gatos High School, and he and I both came back from our summer breaks really excited about teaching this year. He showed me his geometry lesson that he designed through ISME this past summer. And because I teach geometry this year and he didn't, he asked if I would be interested in teaching the lesson. I read it over and it was all about area, and in fact about applying area to real world problems. So of course I said I was excited about it. I had some friends who work in the solar power industry come to class and talk about solar power and its use as a real world application. What was cool about that is they started using all kinds of terms in describing situations like how far out the ladder should be from a roof that you're going to put a panel on. And right away, one of my students raised their hand and said, "Oh, are you talking about the slope?" And then they started talking about the angle of the sun's rays and how it hit the solar panel and how that had to be optimal so that you got the most energy use out of that. And somebody else raised their hand and said, "Is that the angle of elevation?" And so all these terms that we've been teaching the kids all year are now coming into kind of a real world, real life problem solving situation. In fact, it was kind of cool. The first statement out of both of my friends' mouths was, "I use math every day in every aspect of my job, because it doesn't matter how much weight I'm putting on a ladder, how much weight I'm putting on a roof, or what the angle of elevation is, it's all important." So that was kind of cool.
The solar panel design lesson that we did was we tried to fit as many shapes as possible in this rectangular surface so we could get the most energy out of the solar panels as possible. I thought it was fun because we usually just do bookwork, and this was a lot more fun and engaging than what we usually do.
It applied what we learned in math to the outside world and kind of the professions that we might meet up again. The solar panel industry, as well as architectural design, such as the different shapes of the roofs and the angles. So that was really cool.
Well, I learned that what shape your solar panels are is actually important. Different shaped solar panels generate different amounts of energy, so it makes you think about how math can be involved in your life for choosing what you want.
Students are so much more engaged when they're actually doing something. And when I say doing, I don't mean just doing a number of calculations, but actually applying that knowledge of what the calculation is, taking it out of the context of just a book assignment and putting it to real life issues is important to them. And that's when they really get what they're doing. They get it skill-based, they get it in context, and hopefully over the weekend they'll have discussions with their parents about the benefits, in this case, of solar power, but the cost of solar power, and so what makes sense for them in their homes. And it's a good business lesson.
It was also interesting that because of the speaker that was brought in prior to the lesson, some of the kids asked the question, why do we have to use a rectangle to put all of these solar cells on? Why can't we use a hexagon? Why didn't we get a hexagon? And it's like, that's a great question. Maybe next time when we do this, you'll get a hexagon. Those are the kinds of questions that as a teacher you want to be hearing, because it tells you that the kids are thinking and they're problem solving, which is what the whole project was all about in the first place.
The kids were really excited by the end of the lesson today. Just taking an actual chapter and the material that we learn in a book and applying it to something real is kind of a cool thing for them. And so working in groups, collaborating with each other, and then some groups finishing earlier than others, and those students being facilitators of knowledge is beneficial. One, it helps me, because while they think I'm the knower of all knowledge, I'm certainly not. And two, it gets them doing something else that we do every day in our own work lives, which is working in partnership with other people. And so that kind of communication, knowledge transfer is exciting to see in my classroom. And I think they were excited, and I was as well.